The topic we are discussing now is the dynamic memory allocation in C. Before going to this, we'll have just an introduction and why we have to use the dynamic memory allocation in C. See, most in the cases when we are using an array, see these arrays when we are using in C, these are fixed size number of values. This once an array is declared, you must specify what is the size of the array. For example, if I am having some marks array, assume that this is a marks array, and if I want to get marks of n students, I must declare this array with a predefined size, that is int mark of 10 or mark of 20 or mark of 30, that depends upon the number of students. This is one case, and assume that we have this array, and initially I am declaring this array with a length 9. So 0 to 8 I will be having 9 locations, and I am getting the marks of the students, 9 students. And later I feel that the number of students is more, assume that it is 60 or 65 or 70. I need to increase this array, but within a program there is no options to increase the program directly. You cannot reinitialize it directly with the help of the array. That is one of the problem. And the second, the most problem here is when we are declaring an array, that's a huge array with a huge size, uh, the memory that is taken behind the RAM or in the RAM is very huge. Assume that we are having an array of students. That's a structure, array of structure. This is the structure what we are having. I'm just taking an example. So the structure student is having a name, the student is having some register number, age, the degree what the student is doing, the course what the student is doing. I is having some personal address, that's address field 1, address field 2, some city, district, or state, or something else. So these are some personal details of the students. So if we are getting these details of the students and if we are storing it as an array, assuming that I'm having about 1000 students in my uh, college or the class, I have to make the array size to the maximum when we are declaring this array in C. The way we will be declaring is text student is of 1000, and this will take, say, how many memory, uh, the total size of this array. If we are adding all these variables, size of these variables together, it is 672 bytes. So this is for a single structure. Since we are declaring it as a sub 1000, we'll be having 1001 locations, 0 to 1000, we'll be having 1001 locations. So the total size will be 1001 into 672. It will make 2 these bytes, and this is approximately 656 megabytes, and approximately about half GB of RAM is occupied for this variable alone. So if we are declaring 1000 students for the same class, and if we are trying to retrieve the values of the students with the help of a C program in this way, it will take about half the GB of RAM. See how much RAM is consumed, and if you're having more than the values in this array, more GB of RAMs will be occupied, and memory will be filled. So that's a very big problem in C. Again, in not all the cases, we'll be using these 1000 locations. In some cases, the number of students will be 100. Some cases, number of students will be 10 or 20 or 200 or something else. So the rest of the space, it is unnecessarily allocated, and we are not going to use it in this program. So that's a very big problem when we are statically assigning the variables in C. So in order to overcome this problem, C is having a facility called dynamic memory allocation. That is, whenever we need a memory, we can allocate it, and whenever we doesn't need it, we can free the memory. This is the concept behind a dynamic memory allocation. And C is providing some functions to do this. We're having malloc, we're having a C alloc, free, and realloc. We are going to see these functions with respect to C. First is malloc function. So malloc means it is memory allocation. So it will allocate a single large memory in the memory in the RAM. So the syntax here is, and this will return a pointer. So the pointer is equal to the type malloc, the number of bytes. This is how you have to use it. For example, if I am declaring an array, integer array, and this size is defined at the runtime, assume. So assume that we are having an integer pointer. This is for this pointer, and we are having some n and I. This n we are going to get it from runtime. So first we are asking the user to enter the number of elements. Then we have to have a scanf statement here. It is not written. So we'll be having a scanf a percentage d comma this percent n will get the number. Now with the help of this number, we'll be having the pointer. Since we are using an integer array, use it as integer star. Then malloc, then n. This is what we are getting from the user, the size of integer. So the total size will be allocated in the memory for this point. So this is what happening. Now after doing this, if the creation is successful, it will provide a positive integer value, and if it is not successful, it will provide a null value. So we are checking for null. If the pointer is equal to null, the memory is not allocated. We can show some error messages and we can exit here itself. And if it is successful, if we can do the other operations. For example, if we want to assign the values into this array, the pointer array that is dynamically created, we can just use 0 to n for the n times. You can use the scanf statements, or the similar way what I have written here. We can assign the values, that is I plus 1 will be assigned to the location I. So 0 to n, we are having some locations, and these locations will be assigned these values. And the important thing here is it is a single large location. I will give the difference later. Now, coming to CLOC, it is also similar to the malloc function, and the difference here is it will create the blocks of memory that is specified by the user. And second, the block, each block will be assigned with a value 0. So that's the difference here. So previously we are having the same syntax ptr, the type function here is calloc. Here is the difference. In the previous example, we are just having the total size, but here we are specifying the number of elements and then the size of each element. So that's the difference. So when we are declaring this, we'll be using it as ptr ing star calloc, then n, the number of elements, the size of integer. Previously, this was n into the size of integer, the total size. But here the syntax is different. N comma the size of integer, the number of elements comma the size of the integer. So there's a difference here. The other things are same. It will return a pointer. If it is null, you can see that it is not allocated, and you can exit from the program. Otherwise, you can use a for statement similar to the previous program, and you can get the values. Now coming to the difference between calloc and malloc, C, what is happening in the memory. Now I told you malloc, it will create a single block of memory. So this is syntax. If 5 into size of integer means, so it will create 5 into 420 bytes in the memory, and this is a single block. And calloc, see here, if we are having a 5 comma size of integer, it will allocate 5 different memory locations, individual memory location, blocks of locations, each of integer size. Integer size here is 4 bytes. Each 4 bytes will be allocated. Total will be having 20 bytes in the memory. So that's the difference between calloc and malloc. Malloc will create a single block of memory, and calloc it will create individual blocks of the same size of this type what we are specifying here. In this case, integer, so it will take 4 bytes in the memory. And again, this will assign each byte with value 0. So that's the difference between malloc and calloc. Now coming to the next function, free. See, whenever we are using this malloc and calloc, uh, it will not deallocate, or it will not free the memory automatically. So whenever we are writing a program in C, and if we are using an malloc and calloc, we must provide the free statement, otherwise the memory will not be released. It will be there with the program. So in order to free the memory, there's a syntax free of the pointer what we are using. So it will free the memory whatever it is allocated previously. So that's the use of free method. And then realloc is very important. See, there are similar cases where we have declared some variables that is with a size of 5 or 10. Assume that we are having a student database and we have declared 5 students, and later on I think that 5 is not enough, we have to increase the size to 10 students or 20 students. So in those cases we have to redefine the size of the array. So we can use this realloc to do the operation. The syntax here is the pointer is equal to the realloc of the same pointer, comma, the new size. So the allocation will happen here, reallocation will happen here. Now with the help of this new size, we can reduce or we can increase. So if we want to reduce the size, we can reduce the size here. And if we want to increase the size, we can increase the size here. So you can just say example program here for the same. So see the first part, we are having n equal to 5. We are allocating a memory with the help of calloc. So 5 locations are there of the integer size. So 5 to 4, 20 will be allocated in the first case. So now we are assigning the values for the same also. So for this 20 locations, we are assigning the values. Now later on, I think that 5 is not enough, and I need to increase this 5 to 10. Assume I need to increase the size to 10. So since we are increasing size to 10, we need to go for the realloc statement. So realloc the same pointer ptr, it is given here. Ptr is equal to the pointer comma n into the size of integer. N is the new 10 into the size of integer. So it will reallocate the size. Okay. So the new size here is 10 into 4, that is 40. Previously it was 20. Here it is 40. So we are having a new size 40, and now we can do the rest of the operations. That is from 5 to 10, we are having new locations, we are assigning the new values, and you can just print what is the result. Okay. So I have already told you we should use a free statement in order to free the memory size, otherwise it will be always locked with the program. The memory will be locked with the program. So after the use, we are going to use the free statement that will free the memory from the program. So this is how we can use the realloc statement. So whenever we need more memory, or whenever we feel that memory is less, we can use a realloc to resize the memory size of the arrays. So this is the syntax. And one more important thing here, see, we are doing a calloc statement. Calloc means it will be creating individual blocks of size integer. But when we are reallocating it, the individual blocks will not be there. It will be a continuous block, because this is different. You are having the total size, so this is different. So even though if you are using an malloc or calloc, after using realloc, the size will be similar to an malloc statement. You can use both calloc as well as malloc. That is not a problem. But whenever you are using a realloc, the rest of the size will be in similar to the size of an malloc statement. So that is about dynamic memory allocation in C.